Hello! In this video we're going to be looking at fractions, decimals and percentages, and in particular what we're going to be doing is looking at how we can convert between equivalent fractions, decimals and percentages. And if you remember from before, equivalent just means the same, they have the same value. So we're going to be looking at fractions, decimals and percentages which are all worth the same amount. So let's look at what we mean by percentages. So let's break it up into two parts. We've got this first part, per, which just means sort of like out of. And we've got this part, cent, which means 100. So per cent means out of 100. And this cent is sort of the same as in centimetres. We've got 100 centimetres in a metre. Or in currency, if you go to America, say, then 100 cents make a dollar. So percentages just means out of hundreds. I've got this grid here, this big grid, it's 10 by 10, so there's 100 squares in this grid, 100 little squares. And if I were to shade in one of those squares, then we would be pretty happy to say that that is 1 out of 100, isn't it? That's the fraction that I've got. And because it's 1 out of 100, that means it's 1%. So those are equivalent, those are worth the same. 1 out of 100 is the same as 1% because that's what percent means, it means out of 100. So if I were to shade in, let's do a different amount in a different colour, let's say I shade in these 3 squares down here, then what percentage have I got? I hope we're all with me on this. This is 3 out of 100, so that's 3%. Let's go for a slightly trickier one this time. I'm going to shade in 2 whole rows here. So I'm going to shade in all of this bit and all of this bit down here. There we go. So what have I shaded in here? Well, it's definitely 20 out of 100, isn't it? So that means it's 20%. Okay, so we can now see the link between fractions and percentages. Let's have a look at some other examples where we don't have this sort of helpful grid to help us out. So this question is asking us to write 18% as a fraction in its simplest form. Now we've already seen, haven't we, that percent just means out of 100. So if we're going to write 18%, that's going to be 18 out of 100. But this is definitely not yet in its simplest form because I can spot a number that I can divide both of these guys by. 18 and 100 are both even numbers, which means I can divide by 2 on the top. And I can do the same on the bottom. And that will give me a simpler version. That'll be 9 over 50. Now, can I go any simpler than that? Is there any times table that has both 9 and 50 in it? And the answer is no, there's not. That's going to be my final answer. So what is 18% as a fraction in its simplest form? The answer is 9/50ths. Okay, let's try another. We've got now 60%. I want to write 60% as a fraction in its simplest form. So percent means out of 100. So 60% is just going to be 60 out of 100. That's our first step. But we're definitely not yet in our simplest form. What times table are these guys both in? 60 and 100. Well, they're definitely both in the 10 times table, aren't they? So let's start with that. Let's start by dividing by 10. Divide by 10 on the top. We can divide by 10 on the bottom as well. And what do we get then? 60 divided by 10, well, that's 6. 100 divided by 10, well, that's going to be 10. Now, are we done yet? Is that its simplest form? No, I don't think it is yet, because these are both in the 2 times table, aren't they? These are both even numbers, so they must be in the 2 times table. So let's go one more step. I'm going to divide by 2 up here. I'm going to divide by 2 down here. There we go. Which means my final answer is going to be 6 divided by 2 is 3. 10 divided by 2 is 5. My final answer is 3/5. So 60% is the same as, it's equivalent to 60 hundredths, but it's also the same as 6 tenths, and if we go to its simplest form, it's the same as 3/5. Okay, good. We're going to try going the other way now. So I've got 1/4, and I want to write that as a percentage. So let's start with our 1/4 then. Here we go, 1/4. And I know that percentage means out of 100, doesn't it? So I want to sort of do the opposite of our simplifying thing here. I want to change this 4 into 100. So what am I going to have to do? I'm going to have to multiply this 4 by something. Multiply it by 25, I think, aren't I? If I multiply it by 25, 4 times 25, that's going to make 100. So if I'm multiplying by 25 on the bottom, I better do the same thing on the top. So we're going to times by 25 up here as well. And if I do that, 1 times 25, I get, 25. So now we know 1/4 is equivalent to, it's the same as 25 out of 100. And so as a percentage, what's 25 out of 100 as a percentage? Well, it's got to be 25%, hasn't it? Because that's what out of 100 means. 25 out of 100 is the same as 25%. Okay, another. 3/5 as a percentage. We're going to have to do the same trick again. So we start with 3/5. And I want, in order for it to become a percentage, I want to have this denominator, the number on the bottom, I want to make it into 100. So this time we've got to have that same sort of think. What am I, that arrow went a bit weird, didn't it? What am I going to have to multiply by to change this 5 into 100? Well, this time I'm going to have to multiply by 20. So if I'm multiplying by 20 on the top, I'm going to have to do the same on the, if I'm multiplying by 20 on the bottom, I'm going to have to do the same on the top. So we times by 20 up here. And 3 times 20 is 60. So 3/5 is the same as 60/100ths, which is the same as 60%. I think we might even have seen that one earlier, haven't we? Okay, good. So that's how we can change between fractions and percentages. We're going to add an extra one into the mix here, and that extra one is decimals. So I've got a number line. Just here, and we're going to pop some decimal numbers onto the top part of my number line. So I'm going to start with 0 over here. We're going to have 1 over here, which means that, for instance, well, there are 10 divisions. I should say that there are 10 divisions along here. 1, 2, 3, 4, all the way up to 1 over here. So this would be, for instance, 0.1. This would have to be 0.2. Do we see? So 3, 4, 5. This would be 0.5 in the middle there. This would have to be 0.8. And if we label a sort of equivalent number line along the bottom, but instead of with decimals, we're going to label it with percentages, we'd start at 0%, right? 0% is the same as 0, it's nothing. And 1, well, that's 1 is the whole lot, isn't it? So that's going to be the same as 100%. 100%. So those ones are equivalent there. What other equivalents can we get? Well, this 0.5 is halfway along my number line, isn't it? So halfway along my percentage number line is going to be 50%. 50%. And you might have spotted that there's a bit of a similarity here. 0.5, 50%. These numbers are all going to be really similar. So 0.8 is going to give me 80%. 0.1 is going to give me 10%. 0.2, any guesses? 20%. So it's actually really easy to change between decimals and percentages because the numbers are so similar. I'm going to put on a few extra ones. So let's say I had one, a decimal, precisely in between these guys. What would that be? What would that decimal be? So it would be 0.1, 0.2. This is going to be 0.3. This is going to be 0.4. So in between those guys has to be 0.35. What do we think that's going to be as a percentage then? It's 35%. So what we're actually doing to change between percentages and decimals is if I'm going in this direction from decimal to the percentage, I have to multiply by 100. So my 0.35, if I multiply it by 100, I get 35%. And if I'm going the other way, I need to divide by 100. So I start with my 35% in this case, I divide by 100, the answer I get is 0.35. So we're just multiplying and dividing by 100 if we want to change between percentages and decimals. Okay, let's look at some more examples. So we were asked, again, this is one we've seen, isn't it? We were asked to write 35% as a decimal. So 35, we're going to divide it by 100. And if I'm dividing this by 100, we sort of shift all the digits down 2 spaces in their place value columns. So we get 0.35. So 35%, 35% as a decimal is 0.35. Let's try another. 90% as a decimal. So we're starting with our 90%. We're going to divide by 100. We're going to need to move everything down 2 columns, so the 9 comes into the units place, and then behind the decimal point, we're going to get 0.9. That's going to be 90% as a decimal. How about going the other way then? 0.54 as a percentage. So let's start with our 0.54. This time we're going to have to go the other way. We're going to have to multiply by 100. Multiply by 100, so everything's moving up 2 places, and we're going to get 54 this time. 54% is my answer. And one more going this way around. I've got 0.3 as a percentage. 0.3. I'm going to times it by 100. Times it by 100, so everything's going to move up once. Twice, it's going to be, can you guess? It's going to be 30%, isn't it? If I times it, let's write that a bit clearer. 30%. If I multiply by 100, we're going to go all the way up to 30. I said this was the last one, but I think there's one more actually. Yeah, it is 0.03 as a percentage. So very similar to the last one. Got 0.03 though is where we start. I need to times it by 100 again. And the answer I'm going to get is 3%. Because everything moves up twice. So the 3 goes to here and then to here. So that's 3. So if we just compare those last two, 0.3 as a percentage is 30%. 0.03 as a percentage is 3%. Okay. That's an easy trap to fall into where we get those two confused. That one's going to be 30%. That one's going to be 3%. Okay, we're going to get to some trickier ones now. We are asked here to write 1/2 as a decimal and a percentage. So I'm going to do these two in the opposite order. I'm not going to start with the decimal. I'm going to do the percentage first. So in fact, first of all, what I'm going to do is I'm going to write the fraction. We've got a half. We want to change that into a percentage, and we know that percentage just means out of 100. So we're going to need to make sure we get 100 as our denominator. So what do I have to multiply by? We're going to have to multiply 2 by 50 to make it up to 100, don't we? So if I'm doing that on the bottom, we better do the same thing on the top. We're going to multiply by 50. And 1 times 50 is 50. I hope you'll agree. So if 1/2 is the same as 50 hundredths, what's that as a percentage? Well, it's 50%. So that's our sorted. We've done the percentage part. Now we need to do the decimal part. So let's take our percentage. We've got 50%. If I'm changing into a decimal, I'm dividing by 100, aren't I? And 50 divided by 100 is going to be 0.5. So maybe just to write out our answers really clearly, we've got 1/2 is the same as 50%, which is the same as 0.5. 0.5. All of those guys are the same. They're equivalent. Another. 0.8 as a percentage and a fraction. So let's start just by writing what we've got. What we've got is 0.8. And this time I'm going to go for percentage first. If I'm changing 0.8 into a percentage, we're going to have to multiply by 100. And when I multiply by 100, the answer we're going to get is 80%. So there's my percentage sorted. And when I multiply by 100, everything moves up once, twice, so we get 80%. Now we're going to try and change that into a fraction. So 80%, that's 80 out of 100. So that's already a fraction, but we're going to need to simplify this fraction. So what times table are they both in? Well, they're definitely both in the 10 times table, so maybe let's divide by 10. Oh, that's a mess. Let's try that again, sorry. Divide by 10 on the top, and we're going to divide by 10 on the bottom. We're going to end up with an 8 up here and a 10 down here. I think we're going to have to keep going though. What times table are 8 and 10 both in? They're both in the 2 times table, so let's carry on. Divide by 2 on the top. And divide by 2 on the bottom. And now 8 divided by 2 is 4. 10 divided by 2 is 5. So there we go. There's my answer as a fraction. So we've got a decimal, 0.8. We've got a percentage, 80%. And we've got a fraction, 4/5. There we go, 4/5. Cool, good one. Another, 65% as a decimal and a fraction. So 65% is what we're starting with. To change it into a decimal, we're going to have to divide by 100. And if I take my 65 and I divide it by 100, the answer I'm going to get is 0.65. So that's my decimal sorted. As a fraction then, we're going to start with the 65%. 65% means 65 out of 100. But we need to do some simplifying. Now this is a little bit trickier now, isn't it? What times table are 65 and 100 both in? Well, this one ends in a 5, this one ends in a 0. Numbers that look like that are always in the 5 times table, aren't they? So we can divide everything by 5 here. So on the top, I can divide by 5. On the bottom, I can divide by 5. And maybe let's start with the bottom here. How many 5s make 100? Well, it's 20 of them. 20 5s make 100. How many 5s make 65? If you're not sure, you could count up in 5s, couldn't you? That's not too tricky to do. 5, 10, 15, 20. We keep going like that until we get to 65. We'll find out that it's 13. Oops, 13. So the answer to that one is going to be that 65% is equivalent to 0.65, which is also equivalent to, as a fraction, 13/20. There we go. All those three are equivalent. There's two now that I'm going to show you that are a wee bit trickier. And they're tricky because 3, this number on the bottom, isn't easy to change into 100, because what we were doing with all the previous examples was we were going, let's write them over 100, and then we have to say, right, 3 times what makes 100? And the thing is, there isn't a nice whole number that I can multiply 3 by, which will give me the answer 100. So our method here isn't going to work. So what I'm going to do is I'm going to tell you what these are as decimals and as percentages. And I'm going to suggest that the best thing to do with these two in particular, 1/3 and 2/3, is just to remember them. So let's go into a decimal first of all. 1/3 as a decimal is 0.333333, and then those 3's carry on forever and ever and ever. 0.33333333 forever and ever and ever. And obviously, I don't want you to write them out forever and ever and ever. So there are two things we can do. The first thing we can do is write with these recurring, like a whole string of 3's, and then we say dot, dot, dot. Or the other thing that we can do is there's a symbol for this in maths, because mathematicians are lazy and they don't like having to write things out a whole bunch of times. And what we do is we write 0.3 and we just put a little dot over the top. And that dot is called the recurring symbol. And what it means is that this 3 will recur. It'll repeat itself forever and ever and ever. So 0.333333333333 forever. And so that is much simpler than writing either a whole bunch of 3's with some dot, dot, dots afterwards, or in an infinite number of 3's. So that's what we do for 1/3. 1/3 is the same as 0.3 recurring, or 0.33333, etc. Same thing with 2/3 then. If this is 1/3, it makes sense that 2/3 is going to be twice as much. So if I double 0.33333333, the answer I'm going to get is 0.66666666. And we can do the same thing with these sixes. I can either write a bunch of them and then say ... to indicate that those repeat, or I can use our symbol that we learnt before, this recurring symbol, and I can say that that is the same as 0.6 with a little dot above this recurring dot, 0.6 recurring. So those are these ones as decimals. 1/3 is the same as 0.3 recurring. 2/3 is the same as 0.6 recurring. But it would be useful also to know these as percentages, wouldn't it? So as a percentage, we're going to use that trick that we used before. If I multiply this by 100, I will change it into a percentage, and the answer I'll get will be 33.3 recurring, because I'll move all of these digits up 1, 2 spaces. This one will go up 1, 2 spaces, and I'll have 33, and then my decimal point, and then I'll still have infinitely many 3s afterwards. So it's 33.3 recurring percent. And the same thing will happen down here. I'll get 66.6 recurring percent. Okay, so these tricky ones aren't so easy to work out in the same way that I've shown you for the other ones, because this 3 isn't a nice convenient factor of 100. But what we can do is just remember this fact and this fact, and remember our notation, and then that will help us change 2/3 into a decimal or into a percentage, and the same for 1/3 into a decimal and a percentage. Cool. There's one final example we're going to look at, and that is what happens when it's bigger than 1. Well, same as before, really. This question is asking us to write 1.4 as a percentage and a fraction, and we learnt before, didn't we, that if I'm going to change a decimal like 1.4 into a percentage, what we have to do is multiply it by 100. So 1.4 multiplied by 100 is going to be 140. So we get 140%. And you might be thinking, well, what does 140% mean? Can percentages get bigger than 100? And yeah, they can. We can use percentages that are bigger than 100. Sometimes that's useful, especially when things are increasing. So if something has increased by 40%, then what we've got now is 140% of the original amount. So having these percentages that are bigger than 100 are actually quite useful, and that is absolutely fine. So 140%, that's the right answer there. We've changed it into a percentage. And the other thing we were asked to do is change it into a fraction, so let's do that just now. We've got 140% is what we're starting with. So 140 out of 100, that's what percent means, it means out of 100. And we want to do some simplifying here. Definitely we can divide by 10, let's start by doing that. So divide by 10 on the top, we can divide by 10 on the bottom. And that's going to give us 14 on the top and 10 on the bottom. Can we go further than that? Yeah, I think we can. I think we can divide by 2 on the bottom. And we can divide by 2 on the top. Okay, and that's going to give me 7/5. Now we've got it down to its simplest form, but I think we've got another problem here now, haven't we? Because this is an improper fraction. The numerator is bigger than the denominator. So let's change it instead to a mixed number. So if I've got 7/5, how many wholes am I able to make? Well, I've got enough to make 1 whole, and what will be left over? There'll be 2/5 left over, I think. There we go. So let's write them all out at the bottom just so we're clear. 1.4 is the same as, it's equivalent to 140%. And it's also the same as 1 2/5. There we go. Excellent stuff. Okay, I'll see you later, guys. Cheers.